The AI ecosystem is evolving quickly. One important change for developers building RAG and LLM applications is the transition away from the large LangChain Community package. In this video, we will understand what changed with LangChain Community. Why is the ecosystem moving toward smaller packages? How to build a modern RAG application in 2026. A practical example using FastAPI, Ollama, Nomic embeddings, and ChromaDB. Notice that we are no longer using the old LangChain Community package. Instead, LangChain has moved toward a modular ecosystem where each integration has its own focused package. Our dependencies are LangChain for core framework capabilities, LangChain Chroma for Chroma vector database integration, LangChain Ollama for connecting with local Ollama models, LangChain text splitters for breaking documents into smaller chunks, ChromaDB as our local vector database, and finally, FastAPI with Unicorn to build our API service. Now let's look at app.py. This file is responsible for the first stage of our RAG pipeline, converting documents into searchable vector data. We're using the new modular LangChain packages. Ollama embeddings connects our application with the local Ollama embedding model. Chroma provides the vector database integration. Recursive character text splitter helps us divide large documents into smaller meaningful chunks. Here we initialize the embedding model. We are using Nomic embed text, a local embedding model running through Ollama. Next, we load our knowledge document. Large documents cannot always be sent directly to an LLM. Therefore, we split the document into smaller chunks. Here, each chunk contains around 300 characters, with a 50-character overlap between chunks. Now the document is converted into smaller document objects. This is the key step in our RAG pipeline. ChromaDB takes our document chunks and sends them to the embedding model. The generated vectors are stored locally inside the chroma_db directory. Now our application has a searchable knowledge base. Once the process is complete, we know our vector database has been successfully created. The next step is building the FastAPI service that will retrieve relevant information and generate answers using our local LLM. Now let's look at app.py. This file creates the RAG API layer using FastAPI. First, we import the required LangChain modules. Ollama embeddings for document retrieval, Ollama for generating answers, and Chroma for vector database access. We initialize FastAPI and connect to our existing Chroma vector database using the same Nomic embed text embedding model. Next, we configure our local LLM using Ollama with the Llama 3:8b model. The /ask API endpoint receives a user question. The system performs a similarity search in ChromaDB to find the most relevant document chunks. These retrieved chunks are combined into a context and sent to the LLM with a prompt. The LLM generates an answer based only on the retrieved information. Finally, the API returns the question, generated answer, and source documents. This completes our local RAG pipeline. User question, vector search, context retrieval, Ollama LLM, AI answer. Now let's test our RAG application using the API client. Here we are sending a GET request to our FastAPI endpoint, /ask, with the question, how is production capacity calculated? The question is sent as a query parameter. When we click Send, the request goes to our FastAPI service. The RAG pipeline then performs 3 steps. First, it searches ChromaDB to find the most relevant document chunks. Second, it sends the retrieved context along with the question to the local Ollama LLM. Finally, the LLM generates an answer based on our manufacturing knowledge document. This demonstrates a complete local RAG workflow. Question, vector search, context retrieval, LLM response.